Hey everybody, this is Alex Merced from alexmercedcoder.com, and this is the third in my video of data structures. In this video, we're going to be talking about queues. So queue.js. Now a queue is literally like a line at an amusement park. Okay, if you get into a line at the amusement park, you're not the first to go on the ride. So it's not like a stack where the last one in is the first one out. It's actually the other way around. It's the first one in is the first one out. Okay, so basically you will still push things into the queue because it ends up at the end, but basically things will suddenly, really it's going to be, the terminology is going to be queue and dequeue. So queue means you get in the line, dequeue means you got out of the line. So let's bring in our node. So const node equals require node, and again, if you haven't watched the previous videos, do watch them. These are cumulative. These will be building upon each other. Node require node class queue. Okay, and again, the queue is just going to start off as an empty array, similar to many of the previous other ones. Data equals array, because basically what happens is that, like, an array in JavaScript, which is technically not even really an array under the hood, it's actually like a weird class thing. If you take a look at like how it's implemented in the underlying like C++ that creates the engine, but essentially, like, the way arrays are implemented in JavaScript, they have the flexibility of almost all data structures. Okay, and this is why sometimes if you're a JavaScript developer, data structures can seem very sort of abstract, because I can do everything with like an array, so why do I need all these other things? Again, that's not always the case with other languages. Other languages don't necessarily, like languages like Python, Ruby, and JavaScript have data structures like this implemented because they are what's referred to as a higher level language. They've implemented some of these things that wouldn't exist in a lower level language because it makes things easier, but the cost is there's design decisions that could affect performance at large scales. This is why you might end up using a language like Rust, Go, C, C++ for an application that needs more speed. But in those languages, the data structures are much more bare bones. So you oftentimes will have to kind of create your own data structures that fit what you need for your particular application. They'll run a lot faster because you're not dealing with all these like design decisions. You design specifically what you need, but it does require you to understand data structures better. While in JavaScript, Python, Ruby, you just have all that flexibility kind of out of the box. So it's more like you just focus on sort of like, what do I want my code to do, than necessarily how do I enable my code to do what I want it to do. Which is certainly allows you to be more productive, which is why at the end of the day, if you can do it in Python, Ruby, or JavaScript, you'll do that first. You pull out the lower level languages for like things like operating systems, devices, things where you don't necessarily have the luxury of a lot of memory on a client's machine. Okay, but a queue again is like a line. So basically, and then we don't need a constructor because it just has the empty data array. The main thing is how do I put something in the line and take something out of the line. So again, to queue something will be one method, and it will take the data that you want to queue. Okay, so this will add a node to the queue. Okay, so this data will push at the end of the array, and what we're going to be pushing is a new node that contains the data. Okay, so again, a node just represents always like a single unit of information. So our queue is like a line of nodes. Our stack is a stack of nodes. And then, you know, later on we get to things like graphs where we're talking about like, hey, we have a bunch of nodes and then we have a bunch of edges that describe the relationships between those nodes. You'll start seeing like this whole sort of node type structure makes a lot of sense. Okay, and then when something gets out of line, it's to dequeue. Okay, so we don't need to pass anything there. It's just going to take this data, take whatever the first node is. So it's not, I'm not going to use pop. I'm going to use shift. Okay, so this dot data dot shift, and again I'm using the hash because that allows it to be private. So that means I can't directly access the queue's data property. The only way that someone who's using my queue can access it is through these functions. This way I'm restricting my data structure to only do what I want people who use my data structure to do. Okay. Oftentimes you want all the properties to be private, so that way only through the methods you expose publicly do you really, do the methods you expose publicly really determine how someone else can use the thing you made. So that way they can't try to break your thing or misuse your thing in ways that weren't intended. Okay, so this .data shift. Okay, so it's going to shift. It's going to remove the first thing, but again, we have to use the get data method because it's going to pop the first node off the top, and then to get that data, we have to use the get data function off node. And again, if you remember that, that's from the first node video, the first video in the series. That should do it. Now we need to export the queue. Module.exports queue. Actually, we want the uppercase Q. There we go. Now let's go to our Scratch and test it out. So const Q equals require dot slash Q. Okay. So we'll create a new queue. So we'll say const splash mountain line. So this is the line for Splash Mountain over there at Disney equals a new queue. It's a new line. Okay, and then now we're gonna say Splash Mountain line dot queue, meaning someone's getting in line. Bob gets in line. And we'll just do that a few times. So we'll say Bob gets in line. Stacy gets in line. Steve gets in line. Okay, now they finally it's their time to start getting on the ride. Who gets to DQ? So we'll do console.log because we want to console log the results. Splash mountain dot DQ. And again, we don't need to specify a name. We should know exactly who to pull out, whoever was there first, which in this case it should be Bob, Stacy, Steve. Okay, so if this all works, I should get Bob, Stacy, Steve as the output. And I got undefined, 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 which tells me something is not returning what I think it's returning. So let's go back and examine our queue. And it would make sense because I never used the return keyword. That would definitely do it. So let's try that again. And I get Bob, Stacy, Steve, just as expected. Okay, so now I have a queue. And again, there's no way for Steve to jump the line. There's no way for Steve to go first. Because I don't have access to that data property. The only way I can remove things from the data property is DQ, and DQ is always going to move whoever's first in line. And the only way for me to add things is with Q, which will always add things to the back of the line. So the behavior is that of a line of a queue. Okay, and this is technically how most operations will occur in your computer. So when things are being sent to the processor in your computer, they're actually being done through a queue. Every instruction is being added to a line, and then your processor is actually executing those in line. So they're actually building a queue using like assembly language, or actually even more deeper than that. In the way the processor is built, a queue is implemented in the way it handles all the instructions that different software is being given, are giving it. So yeah. So again, stacks, think of like the memory, how everything kind of gets resolved backwards because a function invokes a function, invokes a function. A queue, think of a line, and think of there's a line of different things that are going to the processor and getting executed in the order that they came in. Same thing with request to a server. Okay, and then each of these individual things are a node, an instruction, a piece of data in the set. So my name is Alex Merced from alexmercedcoder.com. Have a great day and enjoy. I'll see you guys in the next video.